Okay, so now that we know how to solve some linear systems by graphing, let's look at some cases that are a little strange, right? See what happens and how we interpret their results. So again, in each case I have two equations that I need to graph, and as we've seen, probably the quickest way to do it is put it in slope-intercept form. So on the first one, when I do that, here's the first equation, right? I'll begin by subtracting x from both sides. It is negative 3y, negative x plus 3. If I divide everybody by negative 3, we get y equals 1/3 x and minus 1. So in this case, my slope is 1/3, and my y-intercept is 0, negative 1. So we'll graph that in a moment, but there's the information for the first equation. For the next one, 2x minus 6y equals negative 12. If we start putting that in slope-intercept form, I'll subtract 2x to begin that journey. We get that. And if I now divide everybody through by negative 6, we get a negative divided by negative is a positive. 2 divided by 6 is 1/3. A negative divided by a negative is a positive. 12 divided by 6 is a plus 2. So the second equation has a slope of 1/3, but a y-intercept of 0, 2. And if you're paying attention, if you remember from chapter 3, here's what's strange, because notice that these lines, right, have the same slope. They have the same direction, but they don't they don't have the same intercept. So they're parallel. And so that means, let's go ahead and look at that. If we graph this first one, we're going to 0, negative 1, up 1, and over 3. Up 1 and over 3, or down 1 and back 3. So here's the graph of the first equation. The second one starts at 0, 2, and goes up 1 and over 3, up 1 and over 3, or down 1 and to the back 3. And so what we have is a situation where we are parallel, which means there's no intersection, and that's not good, right? Because what is our solution? Our solution is a location where they are intersecting. So this case has no solution, right? It's what we call, I think back in the day, we called it a contradiction. Okay, so just like when we're solving equations, sometimes there's a unique solution, conditional, and then sometimes we had a contradiction where there was no solution, and that's what it would look like if we were solving a system. Basically, my lines are parallel. No intersection, no solution. So what's the other strange case? Well, again, let's go ahead and take each equation here and start converting them into slope-intercept form. So we'll begin by subtracting 2x. That gives us 3y equals negative 2x plus 12. If I divide by 3, we get y equals negative 2/3 x plus 4. So slope is negative 2/3. Y-intercept is 0, 4. If we did the other one, I would begin that journey by adding 4x. Right, that gives us a negative 6y equals 4x minus 24. Divide by negative 6, and we get the following, right? Well, positive divided by a negative is a negative, and 4, 6, well, that reduces to 2/3. Negative divided by a negative is a positive. 24 divided by 6 is plus 4. So we have a slope of negative 2/3 and a y-intercept of 0, 4. And you'll notice what happens is we basically have the same line. So they both, right, have 1, 2, 3, 4, and then the slope of negative 2 and over 3. 2 and over 3. So if we were to graph both of them, right, one line, let me even change colors, and the other line lie right on top of each other. So that means there's actually an infinite number of solution points. But when I say this, there's an infinite number of points throughout the plane. The only ones that work are the ones that are on the line. So first of all, we call this an identity, right? That's what we called this back in the day. And the solution is basically the whole line y equals negative 2/3 x plus 4. Any ordered pair that is on that line solves this system because both lines, both equations represent the same line. So there's an infinite number of intersections as they constantly run into each other. And so those are the two strange cases. So most often than not, you're going to have a nice unique pair, conditional. Some of them are parallel lines, meaning no solutions, no intersection. And then some of our systems are identities where the solution is the entire line. And that should wrap up 8.1. We now need to figure out how to do this algebraically, and that's later in Chapter 8.